My name is Gabriella Olsen-Cartwright. I will be presenting on the Le Chatelet's principle for general chemistry 242. In chemistry, the Le Chatelet's principle is very important for its ability to restore, maintain balance in reactions. When stress is applied to a chemical reaction at equilibrium, then the net reaction will go in the direction which relieves stress. In common reactions, the stress is often created by changes made in the concentration of a reactant or a product. The Le Chatelet's principle is also used to find a balance between low temperatures and high pressures in chemical reactions. Scientists are able to predict behavior changes in pressure, temperature, or concentration of a system using the Le Chatelet's principle. The Le Chatelet principle predicts the maximum amount of product in a reaction mixture. The figure shown below is an example for this in the equation N2 gas plus 3H2 gas forms 2 nitrogen, hydrogen 3 gas. When the pressure is decreased, the number of gas molecules increases to maintain equilibrium. The opposite will also be true for an increase of pressure. To maximize productivity, pressure should be high while temperature should be low. The downside of this is that the lower temperature facilitates a slower reaction. One process which utilizes the Le Chatelet principle is the Haber-Bosch process. The Haber-Bosch process is the synthesis of ammonia through nitrogen and hydrogen. It is based on the exothermic reaction. Nitrogen 2 gas plus 3 hydrogen 2 gas forms 2 nitrogen hydrogen 3 gas. Delta H equals negative 92 kilojoules per mole. The diagram in slide 5 demonstrates the Haber-Bosch process. The nitrogen gas and hydrogen gas are heated up with an ion catalyst. Once the gases are cooled, the reaction turns to liquid ammonia. The liquid ammonia then has the ability to be stored and used in the industrial setting. Before this process was created, ammonia was not able to be created in an industrial setting. If it was created too quickly, then there would be a low yield in the product. If it were created in a slow process, the ammonia would have a higher yield, but the process would take too long. Both options were not economically feasible. The Haber-Bosch process is considered the most important chemical synthesis developed in the 20th century. It was one of the first large-scale applications of the Le Chatelet principle. The process gave humans the ability to create an inexpensive source of fixed nitrogen. The nitrogen allows farmers to drastically increase crop production, which is vital to feeding the world's growing population. Its social and economic impact could not be overstated. Special thanks to Chemistry Libre text, Khan Academy, and 8.3 Le Chatelet's principle.